Look at this simple demonstration. When a pencil is obliquely placed in water, it appears to be bent and short. What's the reason behind this? Can you name the phenomenon which accounts for this observation? It is known as refraction. Now let us try to give a theoretical explanation for the observation. Apparent bending of a pencil under water. Look at this ray diagram drawn on the whiteboard. This ray diagram is very important for the board examinations. How to draw the ray diagram of apparent bending of a pencil under water? I will explain it. You can see a pencil is obliquely placed under water. The portion OP is completely immersed in water. When it is seen from above, from air, it appears to be shortened and bent. This is due to refraction of light. We can see that rays of light from the tip of the pencil traveling from water to air. Here the refraction is taking place from water to air. So when the rays of light traveling from denser medium to rarer medium, it bends away from the normal, bending away from the normal and reaches the eyes of an observer. So for an observer, where the image will be seen, the rays of light are not meeting anywhere. So where it will meet? Just produce it backward with a dotted line as shown on the diagram, and the meeting point is at P dash. Now I can say that P dash is the virtual image of P, which is the virtual image of P, and the pencil appears to be bent at OP dash. OP dash. Okay, the ray diagram is complete now. Thus, the part OP of the pencil appears to be bent as P dash O. That is, the immersed part of this pencil appears to be raised and therefore bent at the point O at the surface of water and the stick, and it appears as I can say XOP dash. The pencil appears as bent as XOP dash. Alright, so refraction is responsible for the apparent bending of the pencil, and this ray diagram is important. Remember that you are observing the object from above, from air, and the refraction is taking place from water to air. Clear? Okay. We have seen the apparent bending of a pencil under water when the refraction is taking place from water to air. Now let's check out what happens when the refraction is taking place from air to water. That is, we are keeping an object in rarer medium and we are observing it from the denser medium. Let us see what happens. We will try to explain with the help of a ray diagram. Look at this diagram drawn on the board. An object is kept in the rarer medium, that is in the air, and an observer in water and observing this object. Let us try to complete the ray diagram. So from this object which is placed in rarer medium, the rays of light traveling normally passes undeviated. You know the rule. And the rays of light traveling from object, it suffers refraction at the surface PQ. As the rays of light traveling from rarer medium to denser medium, it bends towards the normal. Draw a normal and rays of light bending towards the normal. And for an observer, where the image will be formed. So image will be formed at the meeting point of this light rays. Where it will form? You just produce it backward with a dotted line. You can see that. Use scale and pencil to draw neat and clean ray diagrams. So it is meeting at the point O dash, and you can see that O dash is the virtual image of the object O in the rarer medium, and it appears to be raised. Clear? So what do you conclude? An object placed in rarer medium, when viewed from denser medium, it appears to be at a greater distance than its real distance. It appears to be raised. Or we can say that it appears to be at a greater distance than its real distance. So this is what happening when refraction is taking place from air to water. Okay, when you are observing an object from air to denser medium, it appears to be closer, and when you are observing an object from denser medium to rarer medium, it appears to be far away. Clear? Okay. So there are many consequences of refraction in our day-to-day life. For example, a person's legs appear to be short when standing in a tank. A tank appears shallow than its actual depth. A print appears to be raised when a glass slab is placed over it. Stars appear to be twinkling in the sky due to change in refractive index of air with the temperature. These all are some of the common consequences of refraction of light that we see or experience in our day-to-day life. Alright, this point is clear to you? Yeah, based on this topic, ray diagram can be asked, that we will discuss in the question answer session. Now let's discuss a board question, previous year board question related to this topic, apparent bending of a pencil underwater. A student puts his pencil into an empty trough and observe the pencil from the position as indicated in the figure. The question is, what change will be observed in the appearance of the pencil when water is poured into the trough? I am pouring water into the trough. As you know that when water is poured into the trough and the pencil is being obliquely immersed, what happens? Refraction is taking place from water to air, and the pencil or the stick appears to be bent. So I can write pencil or stick appears to be bent and raised. All right, because of due to, give the reason also, due to refraction. Due to refraction. Second part is they are asking the reason. In second part, name the phenomenon which accounts for the above stated observation. Of course, it is due to refraction. Due to refraction. Just name the phenomenon. Okay. It appears to be bent and raised. Second part, due to refraction. The third part, it carries 3 marks. Complete the diagram showing how the student's eye sees the pencil through the water. Now let us try to complete the ray diagram. So from the tip of the pencil, rays of light traveling, and it is ready to travel from denser medium to rarer medium. So it bends away from the normal. So one more rays of light traveling. Okay. Again it bends away from the normal, reaches to the eyes of an observer, and for the students, from where the light appear to be coming, the meeting point of intersection of light rays, just produce it backward. Okay, so this is the point, tip of the pencil P, it appears to be raised at P dash. Now from here, join the pencil, it appears to be pencil was X O P. Now it appears as bend as XO P dash. Clear? Yes. Don't forget to put the arrow mark which shows the direction of the light rays. Now the diagram is complete. P dash is the virtual image of P, the tip of the pencil, and it appears to be bent as XO P dash. Is it clear? So you got, after completing the ray diagram, you will get 3 marks.